A way to assess sustainability is by using the ecological footprint analysis. This is a way to define how much impact human activities have on an area, and is measured in terms of area of biological productive land and water required to produce the goods consumed and to assimilate the waste generated. So, in a general way, is the amount of the environment necessary to produce the goods and services necessary to support a particular lifestyle. So you can calculate your own ecological footprint, and you will see how the lifestyle has an impact on the amount of land, the area that is being required. Ecological footprint analysis calculates the land needed to grow the food you eat, support the animals that you eat, produce the fuel that you use for travel, electricity and heating that you use, and also produce the materials in the products that you use, and sequester the CO2 that you generate. We usually link this analysis with the Human Development Index, as we did before. So this is a way of measuring the Earth's biocapacity, or the capacity of the Earth to sustain the development of the humanity. Biocapacity is the productive area that can regenerate what people demand from nature. Footprint and biocapacity can be compared at the individual, regional, national, or global scale. At global scale, you can see in this image how big humanity's demand is compared to what Earth can renew. But this assessment is usually carried out in many sectors, because it enables people to measure and manage the use of resources throughout the economy and explore the sustainability of individual lifestyles, goods and services, organizations, industry sectors, neighborhoods, cities, regions, and nations. So in 2017, the Global Footprint Network estimated humanity's ecological footprint as 1.73 planet Earths. But now the Footprint Network organization reports that the humanity uses equivalent to 1.75 Earths. So we're going to look at the methodology for estimating this ecological footprint, even though I know that, and we are aware that there are many websites where you can calculate these values. But we need to know the information behind these estimations. So the focus of ecological footprint accounting is renewable resources. So all commodities carry with them an embedded amount of land that is necessary to produce them and to sequester the associated waste. So the ecological footprint uses yields of primary products from cropland, forest, grazing land, and fisheries to calculate the area necessary to support a given activity. And biocapacity is measured by calculating the amount of biologically productive land and sea area available to provide the resources a population consumes and to absorb its wastes, given current technology and management practices. So there are different books and literature where you can also get data. What are the technologies being used for energy, for instance, for energy production in Australia, and then it will have a different footprint depending on these biocapacity measurements, depending on on the technology and the management practices. So we can divide the ecological footprint of consumption, and then the ecological footprint of production, and then also the net ecological footprint of trade. Ecological footprint of consumption indicates the consumption of biocapacity by a country's inhabitants. And then production indicates the consumption of biocapacity resulting from production processes within a given geographic area, such as a country or region. And the ecological footprint of imports and exports indicate the use of biocapacity within international trade. So the multi-regional input-output assessments allows you to have estimations on the outputs of the ecological footprint outputs. So in this table, what we can see is the area per person that is needed for different activities. So we have here food and non-alcoholic beverage, and then you have how much is needed in terms of land from crops, grazing products, forest products, fishing products, build up land, and carbon footprint. So I'd like to mention that aside of the ecological footprint, we also there has been other ways of measuring the impact in other important aspects of environmental concern, such as carbon footprint or even water footprint. So looking at this table, we also have health, transportation, communication, education. So everything can be measured in terms of the land that is required. Aside of these areas per person that are needed for these activities or for the production of food or goods, we also need to know the amount of CO2 that is being emitted because of those activities, so we can calculate the area that is needed for carbon sequestration. There are some estimations of carbon sequestration based on forest, on the amount of carbon that is being absorbed by forest, or depending on or other ecosystems. So for these estimations, we need to know, we need to link or associate the ecological footprint with the carbon footprint. So this is probably where lifestyle or also technology plays a key role. So here in this figure, we can see the tons of CO2 that is being emitted per country, but also per a comparison of different foods, right? So we have the leader on carbon emissions, which is the meat, the beef. Then we have also the amount of CO2 that is being emitted per kilogram of chicken, per egg, per glass of milk, even apples or bread. So we need these values in order to estimate the area that is needed for absorption of this CO2 or removal of CO2. So the carbon footprint calculation is something that you will have to do very often throughout your engineering career, because it's being used not only for assessing environmental impacts from the ecological footprint, but also for other methods, such as the life cycle assessment. So let's make an example to calculate the ecological footprint of a person living on a typical Western lifestyle. In this example, we're going to not only focus on the amount of the area needed to sequester the CO2 that is being emitted from the activity of transport. So in this case, we will have the values of the distance. We will need the distance traveled per week, the fuel efficiency of the vehicle. We will need the calorific value of the vehicle and of the fuel. We will need the calorific value of the fuel, and we will need the CO2 yield. So that is the grams of CO2 per megajoule. And in the case, if we are using, for instance, bioethanol, we're going to also need the yield of ethanol that is being produced per area. In addition to this information, we're going to need the tons of CO2 that can be sequestered in the area where this person lives. So, for instance, we're going to assume the value of 1.8 tons of carbon per area per year. And we're also going to assume that this transportation is being used for 4 people. So this person lives in a family of 4, and so we can then have the value in terms of area per person. So the values provided of distance are 200 kilometers per week, 8 liters per 100 kilometers of fuel efficiency, 34.8 megajoules per liter of this is the calorific value of the petrol, and 70 grams of CO2 per megajoule. With these values, we can estimate that the total CO2 emissions from transport will be equal to 2027 kilograms of CO2 per family per year. If we convert this to per person, it will be 507 kilograms of CO2 per person per year. So once we have the value of the kilograms of CO2 per person per year that are emitted, we can now estimate the land that is needed for carbon sequestration. We need first to convert the kilograms of CO2 to kilograms of carbon, and then we can use the conversion factor of what is the area needed for carbon per kilogram of carbon or per ton of carbon. And then we can have a final value of the areas, the hectares per person that are needed for carbon sequestration. And this is equal to 0.077 in the case of using petrol as fuel. Ecological footprint is a good way of measuring sustainability when we focus on the humanity or the wellness of the humanity. But there are some criticisms about this analysis because it really focuses only on the needs, the human needs. So when we look at the calculations of biocapacity of the Earth, this is based directly on what is useful for humans. But there are some lands that are considered unproductive for human use. Also, they are very important. And this land can be degraded or suffer biodiversity loss. And this will not be reflected on the ecological footprint calculations. The other thing that is limiting the useness as a sustainability indicator is that chemical pollution, for example, and other type of environmental impacts are not measured through this method. So this means that a community with a lower ecological footprint than others may not be necessarily more sustainable. Finally, there is a need of more available data. So sometimes we need to have some assumptions due to the data availability. And also, in general, this method focuses on resource consumption rather than pollution.